Thank you for joining me that I can introduce Autoclaved Aerated Concrete to you. Autoclaved Aerated Concrete is also known in a shortcut as AAC. My name is Michael Hoffman. I was raised and born in Germany and I earned my construction degree in Germany as well. It was in 1986. So 10 years later I moved to America to build and to promote for Autoclaved Aerated Concrete. The following presentation will take approximately 45 minutes, so sit back, relax and enjoy the presentation.
MHE International is a company which specialized in design engineering, sales marketing, material supply and construction of autoclaved aerated concrete. AAC has been specified and used in residential, commercial, industrial, hotel and motel, education such as schools and universities, healthcare like hospitals, shaft walls and for sound barrier walls. Let's talk about the AAC history. Actually, it was first found in Germany in 1880, without the present steam curing process. A Swedish architect in 1918 developed the material as it is today, which includes the steam curing process. The first production in America began in 1993. Currently more than 300 AAC manufacturing facilities worldwide, which results in more than 30 million cubic yards produced annually. This is enough AAC for approximately 330 homes every day. Since 1986, MHE has provided for and built successful projects around the globe, and we work closely with each country and every continent and their AAC facilities. It consists basically of water, which later becomes the air once the moisture is removed, aluminum powder or paste, quicklime, gypsum, Portland cement and quartz sand. The cement and quicklime reacts with water in an exothermic reaction to calcium hydroxide and semi-crystallized calcium silicate hydrate. Basically, this reaction stiffens the material. The aluminum reacts with water, and the hydroxide ions which have been made available during the cement and quicklime reaction. So hydrogen gas H2 is generated, which produces the tiny little pores. The percentage used of each raw material is not just a guess. AHC is produced in several different compressive strengths. As more H2O is introduced, we produce a lighter material and we increase the R value. However, decrease structural values and decrease the sound value. But if we use more quartz sand, for example increase the volume to 70%, we increase the structural value and increase the sound value. However, decrease the steady state R value. The final hydration product is also called turbomerite, as seen here under a microscope. You can see numerous air pockets, however not all are connected, which gives AAC the unique properties. Most AAC facilities are well advanced and have just a few workers. Everything is computerized and robots pouring, moving and autoclaving the product. The technology today makes it possible that each mixture ratio is very accurate, controlled by computers, and the material has just 1/32 of an inch size differential. When producing AAC with quartz sand, the ball mill will assure the grinding of the proper consistency of the sand, which is wet grinded. There are few manufacturers which are using fly ash instead of sand. Those facilities do not require the ball mill. Basically it begins with the sand, which is the dominant raw material. The sand will be mixed with water in large slurry tanks. When we produce reinforced units, which are wall panels or floor panels or roof panels, we receive the reinforcement in form of spools. Those spools will be straightened and cut to length. Then the fully automated reinforcement cage welding machine connects our longitudinal and latitudinal bars together in the spacing as our engineers have it designed. These are completed welded reinforcement cages, designed to specification for either floor, roof or wall panels. Before we introduce the reinforcement cages into our mixed raw material mold, we protect the cages with a corrosion treatment. Here we pour the pre-mixed raw material in our forms. In this curing room, the aluminum paste finds this reaction. As you can see on the top right picture, there is a 3 to 4 inch space. Then after 8 to 10 hours, the reaction is completed and the AAC in the green stage did rise to the top of the form. Also the cement reaction occurred so that the material is stiffen enough that we can unmold the AAC. Now the material is ready to be cut to size. As you can see here, those wires, very fine wires like piano wires, will cut the material in 2-inch increments. Will cut the material very accurate. All remaining materials which is cut off will be recycled and is being reused. Recycling and reuse of material is very important to us. So the material which was just cut off will be reused, and also recycling silos will store and use recycled raw materials. So in order to cut those profiles into our wall, roof or floor panels, we use those profile knives right after the wire cutting process. This is a vertical load-bearing panel without a profile. This is a vertical load-bearing panel with a half-round profile to add a vertical reinforcement in the center of the wall thickness, in a spacing required by the engineer, which is in accordance with your local requirement. This is a panel with 2 half-round profiles, used when the vertical reinforcement spacing is every 24 inch on center. This is a horizontal panel used mostly for cladding on structural steel or concrete. The last panel is one of our floor panel profiles, which is also available in tongue and groove. Here's the most important part of the process, the autoclave. Also here we are very energy efficient. Before discharging an autoclave, which holds 12 bar of pressure and a temperature of 350 Fahrenheit for about 10 hours, we reuse the remaining steam by loading a new autoclave with the material, closing the autoclave, and then using the steam from an autoclave which is ready for discharging. So we push the remaining energy from autoclave to autoclave. So after about 10 hours the material is ready for discharge. The material has approximately 30% of water content. During transportation, delivery and installation, it will lose approximately 15%. The normal and healthy water content is between 4 to 8%. We also produce U-blocks, or as known in the masonry industry as knockout blocks. Those blocks will be used for tie beam, or known as bond beams, or for window and door headers. This could be your panels, waiting for our freight company to pick them up and deliver to your job site. See how easy it is to build a house with pre-engineered panels. Vertical load-bearing panels, header panels or lintels for door and window openings, floor panels for multi-story buildings, all produced to size with a tolerance of 1/16 of an inch, which is 1.8 millimeter, and marked for easier and faster installation. And also here, reinforced panels for the second floor. We can install a panel every 3 to 5 minutes. Roof panels to create a fire-rated envelope and for maximum thermal performance and achieving a true 100% green and sustainable envelope. Easy completion with traditional roofing material, adding the gutter system, installing doors and windows, and even adding an autoclaved aerated concrete chimney. Please see our website or find us at YouTube to see actual buildings built with reinforcement panels within just a couple of days. What are the advantages of using autoclaved aerated concretes on your projects? AAC has the highest fire rating in the industry for non-load-bearing wall applications in the United Laboratory certified AAC for 1 hour per inch, which is outstanding in the construction.